Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Ethylbenzene is treated with HNO3H2SO4 mixed acid nitration conditions to give a dinitro product A. The ethyl group is an ortho-para director. With two equivalents of nitrating agent, the two nitro groups enter at the ortho and para positions relative to the ethyl group, giving 1-ethyl 2,4-dinitrobenzene as the major dinitro product A. The 1-2-4 substitution pattern is strongly favored over 1-2-3 because the second nitration is directed para to the first nitro group's deactivating effect, landing at position 4 relative to the ring, consistent with the ethyl group directing. Moving on to the next step. Hot concentrated KMNO4 oxidize the alkyl side chain, ethyl group, on the benzene ring to a carboxylic acid, -CoO, regardless of chain length. Thus 1-ethyl 2,4-dinitrobenzene is oxidized to 2,4-dinitrobenzoic acid, B benzene ring with CoO at C1, NO2 at C2, NO2 at C4. And for the final step, SOCl2, thionyl chloride, converts a carboxylic acid, -CoO, to an acid chloride, COCl. Therefore 2,4-dinitrobenzoic acid, B, is converted to 2,4-dinitrobenzoyl chloride, C benzene ring with C, is equal to O, Cl at C1, NO2 at C2, NO2 at C4. This corresponds to option B, drawn as O is equal to CCl on the ring with number 2 at ortho and para positions. Why other options fail? Option A shows the same connectivity as B, but uses COCl notation ambiguously placed. Option B more clearly and correctly depicts the acid chloride as O is equal to CCl, which is the standard representation of an acyl chloride product. Options C and D show the ethyl group still intact, meaning no oxidation by KMNO4 occurred, which is incorrect since KMNO4 heat oxidize alkyl chains to CoO. Option D shows a 2,3-dinitro pattern, which is not the expected regiochemistry from nitration of ethylbenzene. Therefore, the correct answer is B. Therefore, the correct answer is option B.